All right. Hey, Econ 180 folks. I got a question about the second problem on the homework, number 8.3 in the book. Is that right? 8.3? Yeah. And so I wanted to go ahead and give you guys a heads up on how to go through that problem. I think once we go through it, you'll be like, oh, that makes total sense. So hopefully this is a nice little assist for you all. So basically this is a local public good problem. Says we've got 3 people in a community and they're trying to decide what the socially optimal level of a public park to have. We have 3 consumers, 1, 2, and 3. They each have different demands, and their demands are given as person 1 has demand equal to 40 minus z, where z is the level of park. Demand 2 is given as 30 minus z, and demand 3 is given as 20 minus z. And so the first part of the question asks you to find the height of the sum of those, the marginal social benefit curve. And so that's going to be the summation, which is just going to be the sum of those 3 demand curves. So 40 minus z plus 30 minus z plus 20 minus z, or 90 minus 3z. And then what you want to do is go ahead and graph those 3 curves. So once you've got all that, you can go ahead and do that. So I'm going to erase my demand curves and then go ahead and graph that. And so I'm going to have the cost associated with this good provision, and then I'm going to go ahead and have the quantity of public good being provided, little z. And to solve for those demand curves, you want to do what we've done in the past, which is you want to go ahead and solve for the endpoints. So give me 1 second here. So I've got my little board so I could do my math on it. So we've got, for example, demand 3 is equal to 20 minus z. So I could find the point where we can determine how much they value a level of z equal to 0 and how much z they demand when d is equal to 0. And that'll give me my 2 endpoints. So if d is equal to 0, then it's just going to be 20 minus z. Add z to both sides, and I get z equal to 20 when d is equal to 3 or to 0. On the other hand, if z is equal to 0, then we just end up with 20. So our endpoints are going to be 20, 20, and it's going to be the same, right? It's pretty straightforward. The math on that part is pretty easy, so hopefully you're comfortable with that. So we're going to have demand 3 is 20, 20. Demand 4 is going to be a little bit lower. Oh, maybe not. 30. Let's do these in one color. Try to keep them symmetrical. 30. And then the next one is going to be 40 and 40. So those are my 3 demand curves for consumer 3, consumer 2, and consumer 1. And then the next thing I want to go ahead and do is solve for the endpoints for my summation curve, right? My marginal social benefit curve. And that's going to be d summation, or marginal social benefit, is equal to 90 minus 3z. So if I want to solve for when d is equal to 0, that's just going to be 90 minus 3z. Add 3z to both sides, and then divide by 3, and I get 30. And then on the other hand, if I set z equal to 0 instead of d, then I'm going to just get d summation is equal to 90 minus 3 times 0, or D summation is equal to 90. So those are going to be my two endpoints. I'm going to have when the price of our public good is 0, consumers will demand 30, say, square acres of park. And when the maximum they're willing to pay for the first unit of park, or the first square foot of park, is going to be a price of 90. So I want to go ahead and put that into my graph next. So I'm going to say I've got one endpoint here at 30. The other one's going to be at 90. So let's say that's 50, 60, 70, 80, 90. Oh, come on. Make those numbers look nice. Here we go. And then let's make that our marginal social benefit curve. So it's going to be going from kind of a straight edge in here so it doesn't look like crap. And it still looks like crap, but that's okay. I'm going to do something a little bit better with it. Let's give us a nice big round one. There we go. And so that's going to be our D summation, which is equal to our marginal social benefit. The next part of the problem says that you want to drop everything really loudly on the floor. And definitely don't reset your recording because you want students to know how much you're struggling too. Okay, so now we've got the cost of the park in terms of land per acre is given as C, and it's 9. So we're going to say 9 is the cost per acre of park. That's our marginal social cost. And so what we want to do, we want to do two things. The first thing we want to do is we want to set D summation, or our marginal social benefit curve, equal to 9. So we want to set D summation equal to C. So that's going to be 9 is equal to 90 minus 3z. We can add 3z to both sides and subtract 9 from both sides. And we get 3z equal to 81, or z is equal to 81 divided by 3, or 27. And so that's going to be our social optimum. Yay! So that's where our equilibrium park size is going to be, or our socially optimal park size is going to be. So we want to go ahead and impose that cost line here. And so it's going to be $9. I'm going to pop that down here maybe like this. That looks terrible. So let's try it again. And that's our cost. And it's at $9. And that means that our equilibrium is going to be right here at 27 acres of park. Cool? Makes sense? Kind of weird, small amount of park considering how high the demand is. But the demand goes down really fast. That socially optimal level of demand drops really, really quickly. So that's probably part of it. So now we have the cost of parkland per acre, denoted by C, is 9. Give the cost of parkland and compute the socially optimal level, the number of acres of parkland in the city. We've done that. We're good. Part C, compute the level of social welfare at the optimal Z. This is just the area of the surplus triangle between DZ and the cost line, right? It is like calculating, the social welfare is equal to the consumer surplus associated with this marginal social benefit curve and the cost curve. So it's going to be this triangle here. We do a little bit of area of triangles today in this week in these homework assignments. And so to calculate the area of that triangle, it's going to be the, what does it call it? The social welfare is going to be equal to the area of a triangle with a height of 90 minus 9, or 81 and 0 to 27. So, oops, not minus, times. So if I go ahead and look at clear 81 times 27, I'm going to get a value of 2,187. And 1/2 of that is going to be $1,093.50. So that is the social welfare associated with the socially optimal level of park provision for this community with these people in it. So that's problem 2. So now you know how to do the 2 big problems or at least most of the 2 big problems in the homework. Hopefully that gives you guys some good information. Let me know what questions you have. If you have questions about the other 2 problems, which I think are pretty straightforward and shouldn't be too onerous. You don't have to do the other parts of the question, but they are interesting. So the next part asks what to do if there are 2 other jurisdictions with 3 consumers just like the given ones. Basically, what would happen if we had a T-bow style sorting and we had jurisdictions with all D3 people, all D2 people, and all D1 people. Then what we'd see would be those homogeneous jurisdictions would probably have higher levels of consumer surplus. So that's the next step in that, but it's not on the homework assignment. You don't have to do it. We can talk about it if you'd like to. So let me know what you think. Let me know if you have other questions about this chapter, the public goods chapter, the pollution chapter, or anything else we're going over, or if you've got anything else going on that I might be able to help with. Be well, stay safe, wash your hands, and have a good rest of the day. All right. Thank you, guys.